My name is Justin Cook, and today I'm going to be showing you how to make thin films for the demonstrative speech for Communications 1010. So thin films are exactly what they sound like. They're thin layers of material deposited on a substrate in some way. So here's a schematic of a thin film. So this large region down here is what we call the substrate, which is the material that we deposit the film onto. And then this thin layer on top is the actual thin film. And the thickness of the thin film is much less than that of the substrate. So the thickness here, D, for thin films are typically on the order of nanometers to microns, which is 10 to the minus 9 to 10 to the minus 6 meters. So today I'm going to show you how to make thin films via the spin coating deposition method. And we're actually going to spin coat this type of glass right here, arsenic sulfide glass, with this chemical composition. So if we come over here, so for this process it's a solution-based process. So what we actually do is we dissolve the glass here in an organic solvent, and we put a magnetic stirrer in there, and then we place it here onto the hot pad, which has a magnetic stirrer built in. And the stirrer will mix the solution until the glass is fully dissolved, which usually takes about a week. So now we're going to go ahead and actually make a thin film. So the first step in this is we want to turn the stirrer off, and then we want to turn the heating on, because when we make these films, since they have liquid in them, once we deposit them, we want to heat the film up so that the liquid can evaporate off and we just have solution left. So right now we're going to set this to 75 Celsius, which is just below the boiling point of our solvent, and that'll allow us to make the film and not destroy the surface. So to actually make the film, we come over here to what's called our spin coater, which is the machine that we're going to use to deposit the film. So what we do is we take a clear glass substrate, we use microscope slides and cut them into thirds so that they're 1 inch square, and we come over here onto the spin coater, and I'm going to turn it on, and then we're going to secure our substrate into the spin coater by use of a vacuum. And the vacuum is actually going to be here on this knob. It's connected to the spin coater. And then what we're going to do is we're going to load up this program that I've made to actually deposit this film. So what the program does is it tells it to wait 7 seconds and then spin for 20 seconds. And these parameters have all been experimentally determined previously. So what we do is we take a pipette from any normal chemistry lab, and we get some of our solution into the pipette. And we're going to be pipetting 100 microliters onto this substrate. So what we do is we deposit the solution onto the substrate, and then we run it. And what this will do, like I said, is it's going to wait for 7 seconds and then spin for 20 seconds. Now that the film is done spinning, all we have left to do is turn off the vacuum and transfer our film to the annealing stage so that the solvent can evaporate off. And now that we have the film here on the annealing plate, in about 20 minutes that's going to be set and the solvent's going to be evaporated off. And that's how you make spin-coated films out of chalcogenide glass.